I don't know, some unwanted. Uh, yes, now everything is fine, I feel. Okay. We'll directly go to, okay, we are discussing something, but unfortunately some internet problem occurred, okay, due to this. Okay. Now, we will start, okay, in today's class. Let me start once again. What? Lens makers formula. Very important. 5 marks. Okay? Okay. No, no problem, I feel. This is very important derivation in this chapter and little confusing. Usually, student go wrong while putting minus sign on those things. Okay? Here, let me try to derive this derivation as much as simple possible in its simplest form. Actually, I'm not deriving exactly as given in textbook. From our department, some of the subject experts, physics subject experts, they gave another what derivation for this equation, where in the month of January or February of this year 2020, a refresher course for physics teachers, physics lecturers, they are given this equation. This is equally valid. Okay, no problem in that. This is very much simple. To start, listen. We know this that refraction to Earth surface, where an object placed at certain distance, okay, this is O, this is I, this is C, this is angle I, this is angle R, this is refractive index N1, say this is P, this distance is U, and this distance is V, of course this distance is R. We have derived a relation connecting the U, V, N and R. This is angle. Okay? We have derived this relation connecting U, V, N and R in the form N2 by V minus N1 by U is equal to N2 minus N1 divided by R. Fine. See, let us understand this equation. This equation is refractive index of image space. This is image. This is refractive index. Let me repeat. Please listen carefully. Listen carefully. Let me repeat the things. This equation, according to this equation, refractive index of image space divided by image distance. Let me repeat. Refractive index of image space divided by image distance, or refractive index of space where refracted ray present. What? Refractive index of the space where refracted ray present divided by image distance minus n1. Refractive index of object space means where object present divided by what? object distance. Refractive index of object space divided by object distance, or refractive index of the space where incident ray present, or refractive index of the space where image ray present. Incident ray present. Refractive index of the space where incident ray present divided by object distance is equal to difference into minus n1 divided by r. If you are very much familiar with this equation, then we can solve this Lenz-Nichols formula very easily. How? Let us see. Okay. Let me draw a lens. A principal axis. A ray of light is also incident along principal axis. Let us consider a point object O and which is incident at point, say, capital N or N1. Here we observe refraction takes place. N1, this is rarer medium. N2, this is denser medium inside the glass, inside the lens. After refraction, the ray of light will meet principal axis, visible principal axis at point I. Now, this is object O placed in rarer medium. Right here, rarer medium. This is the image form once again in rarer medium, say N1. Okay. Imagine this lens is made up of two surfaces. Of course, this lens is made up of two surfaces, ABC and ADC. Imagine ADC, surface ADC is absent for time being. ಅಂದ್ಕೊಳ್ಳಿ ADC ಇಲ್ಲ. ADC ಇದ್ದಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಇಷ್ಟೇ ಆಗುತ್ತೆ. ಇಲ್ಲಿ A, B, C ಮತ್ತೆ ರೇ ಆಫ್ ಲೈಟ್ ಮತ್ತೆ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಇದು ಒಂದು C, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? In the absence of ADC, this is your object, this is your image, this is angle of incidence, this angle of refraction, this is C, this is R, this is U, this is B. Correct? Exactly similar figure where you have drawn in case of refraction at spherical surface. Same figure we have drawn here. Correct? Where in the absence of ADC. In the absence of ADC, what we observe? This ray of light would have traveled this distance. Say I dash. I am not taking I1. You can take I1 also. I am taking I dash. This I dash is an image formed in the absence of ADC. ADC illde ಹೋಗಿದ್ದಿದ್ರೆ after refraction I dash ಕಡೆ ಏನು ಹೋಗ್ತಿತ್ತು, ಲೈಟ್ ಹೋಗ್ತಾ ಇತ್ತು ಮತ್ತೆ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇತ್ತು. ಒಂದು ಲೈಟಿಂಗ್ ಹೋಗ್ತಾ ಇತ್ತು, ಲೈಟಿಂಗ್ ಹೋಗ್ತಾ ಇತ್ತು, ಅವೆರಡು ಮೀಟ್ ಆಗೋ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇತ್ತು. Due to presence of second surface like ADC, the ray undergo second refraction. First refraction is between air and glass medium. This is air, I mean rarer and denser medium. Say this is rarer medium, this is denser medium at point N1. Second refraction is at N2, where ray of light once again undergoes what? Refraction. Here refraction is between dense half to error, dense half to error. Hope you understood. Two refraction we observe. One refraction from error to denser, second refraction denser to error. Error to denser, denser to error. Due to this two diffraction, double refraction, final image is formed at V. If this is a midpoint O, let me write V be the real image distance. Let V dash be the distance of image in the absence of second surface. Second surface illa ankondidre adu enaagtade, this is a V dash. And we know U be your object distance. U enagirli object distance agide. Now I have great explanation. How? Let us consider a thin convex lens of focal length and limit of radial curvature R1 and R2. Why R1 and R2? See, this forms one sphere, this forms one sphere, then definitely this is C1 shape for time being, then this will be R1. Okay? This is C2 shape, this is R2. Hope you understood. We have radial curvature R1 and R2. A point object is placed on principal axis at a distance u from optical center. A ray of light is incident from point O at point N1 say. Then after refraction, it will meet at a point I on principal axis. In the absence of second surface say ADC, the light would have traveled and meet the principal axis at I dash. This is an initial explanation you are supposed to write. Fine? Now, let's put it. Here let me write C1 because we have exactly two surfaces. One ABC, one ADC. So this will be R1. Now, let me write here in available space only. Refraction at surface ABC. This is Roman number 1. I am writing Roman number 1 here. Refraction at surface ABC. Okay. For surface ABC, see here what is your formula for refraction at curved surface. Formula for curved surface is N2 by V minus N1 by U, which is equal to N2 minus N1 by R. This is standard formula, right? Okay. Now, for ABC, let us modify this equation. How? Let us see. According to our formula, refractive index of image space. This is N1. Here we have considered inside the lens. This is N2. Refractive index of image space. Here is image. This is image space. Here refractive index is N2. No problem in that. I hope you understood. No problem. Correct? Refractive index of image space. No problem. Divided by image distance. What is image distance here? Tell me, what is image distance? This is U, object distance. Here, V dash. V dash is the image distance. Why V dash is the image distance? See, in the absence of second surface, V dash is the image distance. So, in the place of V, we are supposed to write V dash. Why? Because formula is refractive index of image space divided by image distance. Here image distance is V dash. In this case, image distance is V dash minus. I will just use this formula only. No sign convention, nothing, nothing, nothing. We have one more method as given in your textbook. We can follow that also. Little confusion. If you say yes, I will try that method also. No problem in that. That's quite interesting. This is simple. That's all. Okay. Now minus. What next? Refractive index of object space, where object is situated according to our formula. This is refractive index of object space. Say L1 divided by object distance. What is object distance? U, which is equal to n2 minus n1. As before we have, you write directly n2 minus n1. Visible? Yes. What about R? Here R is in this case R1, C is C1. So let me write it as R1, equation 1. Hope you understood. Hope you understood. Refractive index of image space divided by image distance V dash minus is in this formula only. Refractive index of object space divided by object distance is equal to difference in Ri divided by radius of curvature. For this surface, radius of curvature is R1. If you are perfect in this, let's move next. Okay? Okay. Now, okay, let me write here. Available space, right? Second point. Roman number 2. Refraction through surface ADC or you can use this formula also here. See here. Okay. Refractive index of space where refracted ray present divided by image distance minus refractive index of the space where incident ray is present divided by what? Object distance. Okay. Now let me draw ADC here. Just I will draw ADC. This is A, this is D, this is C. What we have? We have somewhere here I dash, which is at a distance of V dash. Somewhere here, what? I, real image, at a distance of V, and here C2. This distance is R2. Here your ray present, what ray? Incident ray. Correct. This must be. Now remember, this is N2, correct? This is N1. As I said earlier, you have to keep in mind final image is formed in rarer medium. Final image is formed in rarer medium. Your object is placed in rarer medium. See here, this is object, rarer medium. This is image, final image, rarer medium. If you know this, then your derivation will be very easy. Now let me write expression for this. Look carefully. What I have to write? Refractive index of image space. Refractive index of image space divided by image distance. Where your image is formed? Your image is formed in rarer medium. Of course, in rarer medium. See here, your image is formed in rarer medium. So your formula is refractive index of rarer medium. Refractive index of image space. Image space here N1 is image space. Image space where final image is formed divided by distance V divided by V minus Refractive index of object space. Where is your object? Where is your object? Remember, for this surface ADC, this portion is not there, correct? We have only ADC. This I dash acts as virtual object. This I dash acts as virtual object. Due to this virtual object only, we get this final image. We have to imagine that. A virtual object, this I dash acts as virtual object, not this real image. Where this virtual object is formed? Actually, this virtual object is formed inside the lens only. Inside the lens only. In the absence of second surface, it would have formed here. ನಿಮ್ಮ ವರ್ಚುವಲ್ ಆಬ್ಜೆಕ್ಟ್ ಲೆನ್ಸ್ ಒಳಗಡೆ ಆಗ್ತದೆ. ಅದನ್ನ ನಾವೇನ್ ಮಾಡಿದ್ದೇವೆ, we just spaced it. Okay, then we have just spaced it. We just spaced it and shown I dash as in the absence of second surface, your ray would have traveled this distance and your image would have formed here. But there is second surface. Hence, your image will form inside the lens, and this image acts as a virtual object. So, object space will be into here. This is image space. Final image is formed in rare medium. Where is object? Object is inside the lens. We have shown here. In the absence of lens, it will form here. It will be formed here. But the image is, we have what we have to take? The what object space. Object space will be n2 divided by what is object distance here? Of course, p dash. Still confusion? We will go to next explanation. What? Or we can think this equation as refractive index of the space where refracted ray is present. This is a refracted ray. Refractive index of space where refracted ray is present. This is refracted ray. Refractive index of this refracted ray is n1. Hope you understood. Listen, my words, my sentence. My sentence word by word. My sentence word by word. Refractive index of space where refracted ray present is n1 divided by image distance, of course, minus is in the formula only. Refractive index of the space where incident ray is present. Where is incident ray? Here we have incident ray. This is not at all incident ray. Here we have incident ray. This is the refractive index where incident ray present. Refractive index of the space where image incident ray is present. Refractive index of space where incident ray is present. This is incident ray. It is present in n2 and object distance. Object distance is nothing but here v dash is equal to what? According to formula, n1 minus n2 we get. Here, see here. n2 minus n1, here n1 minus n2. Of course, it's n1 minus n2. According to this formula, if you follow this formula, what I have write n1 minus n2 divided by. I am not using any sign convention here. We can use sign convention 2 times and get the equation. Here I am not at all using any sign convention. Just putting the values as given in what? As there in formula. I am not using any sign convention. Okay. Here, what is R? We know this distance is R now. So automatically we can write it as R2 for second surface. Hope you understand. See, this minus this here is this side. RHS. This minus this. I have simply written n1 minus n2 divided by r2. Now this surface is r2. Okay. Now let me arrange the terms. n1 by v minus n2 by v dash is equal to, I will write like this, n2 minus n1 divided by minus r2. This is equation 2. We can write, right? Rearrange the terms. Just take minus and out, n2 minus n1 divided by minus r2. So this is equation 2, this is equation 1. Now RHS, we can add equation 1 and 2. Okay. Now adding equations 1 and 2. What we have? Equations 1 and 2. So equation 1 is n2 by v dash minus n1 by u plus n1 by v minus n2 by v dash is equal to, see, I can write here easily n2 by n1 into bracket 1 by r1 minus 1 by r2. Just n2 minus n1 common. See these three equations. What? This is happened. Now these two equations and this. These two equations and this. Okay. Now this n2 by v can cancel. I will write this equation as n1 into bracket 1 by v minus 1 by u. I can take n1 common, right? Is equal to n2 minus n1 1 divided by r1 minus 1 divided by r2. Okay, I need this. Still need this. Now I can cross multiply like 1 by v minus 1 by u is equal to n2 minus n1 by, okay, n1, correct? Sorry, 1 divided by r1 minus 1 divided by r2. Hope you understand. Simplification. Now, say this here. We have somewhere here object kept, correct? At a distance u. Imagine you are placing this object at infinity, visible at infinity. When this is a lens, okay, in higher, let me take some other lens. When your object is placed at infinity, say infinity, then the ray of light after reflection will form image at depth. Let me repeat slowly. Imagine you are placing this object at infinity. Let me repeat. Imagine you are placing this object at infinity. This distance u is equal to infinity now. U is equal to infinity. What you need? You just put that object and place it at infinity. When you place object at infinity, what will be the nature of your image? Your image will fall at principal focus such that v is equal to f. Why f? This distance itself is f. Here, your image distance will be equal to focal length of lens. Why? Remember, whenever object is placed at infinity in front of lens or mirror, let's take lens only, image is formed at at F, where F is principal focus. Now your image distance is infinity. Your object distance is infinity. Automatically, your image distance will become focal length of the lens. Why focal length? The distance between principal focus and optical center is automatically focal length. So, when u is equal to infinity, v will be f. Remember, no sign convention I used here. We can solve by using sign convention also, as we were explored. Repeatedly, I am telling you. Okay. Now, 1 by v, instead of 1 by v, I have written out 1 by f is equal to 1 by u means 1 by infinity, which is equal to 0. It vanishes. No need to write. This term will be equal to 0. No need to write. I will write it as n2 by n1 minus 1. Correct? Simply dividing all the 6, you can write, right? Into bracket 1 divided by r1 minus 1 divided by r2. Hope you understand. Or finally, what we can write? I can write 1 by f is equal to n2 1. Why? Into by n1 is n2 1. We have said already these things. Divided by minus 1 into bracket 1 by r1 minus 1 by r2. This is called lens maker's formula used by lens makers, a person, technician who prepare lens. This is called lens maker's formula. This is easiest available method to derive this equation. Okay, hope you understood. Next, we have a concept called thin lens. What? Thin lens. What is thin lens? What is thin lens? Okay, I will stop. The last concept is thin lens. Okay. Thin lens. Very important. This is important for next derivation. Important. What is thin lens? A lens whose thickness is negligible as compared to radii. The lens is called thin lens. A lens whose thickness is negligible as compared to its radii, then the lens is called thin lens. We have one formula called thin lens formula. What? Thin lens formula. Remember this as it is. What's thin lens formula? Thin lens formula is given by 1 by v minus 1 by u is equal to 1 by f. If you put plus here, it will become mirror equation. Don't confuse mirror equation. Don't confuse this equation with mirror equation. This is 1 by v minus 1 by u is equal to 1 by f. Let me repeat. This equation is 1 by v minus 1 by u 1 by f. No need to bother how to derive all those things. Just remember this. Just directly remember this. This is thin lens equation. Thin lens formula. What is thin lens? As we have discussed, thin lens is the lens. We can neglect its thickness as compared to radii. Why not thick lens? In case of thick lens, okay, there is lateral shift or lateral displacement between incident ray and emergent ray. There is lateral displacement. To avoid lateral displacement, we use thin lens. In thin lens, a ray of light incident at O will pass without radiation. If the size of lens is thick, then what? There is two distinct lines. There is some parallel displacement, perpendicular, what we call lateral displacement between incident ray and emergent ray. To avoid that confusion, we use thin lenses. We use only thin lenses. sentence. Okay. Last words. Let's stop here. Dear students, what you have to do? You have to write notes regularly. Read all the notes. Okay. We have no time. Already it's September. Okay. After Vasham Ritu, you have to read every notes, each point, and discuss with your friends, with your teachers. Then you have to go through the videos very carefully. Go through the videos very carefully. If still you have read, you can contact us. But please read and read. Don't waste time. Time is precious. Thank you. Tomorrow we will continue. Okay? Thank you.